webinar. There's the American voice to tell us so, but welcome to those of you who are joining us. We'll just give it a few more moments for people to click on the relevant buttons and fill up their teacups. Just bear with us for a moment or two and we'll get started really shortly. It's a pleasure to welcome you all to this webinar this morning. We've not been doing so many webinars over the summer. I think people have been keen to get back out and fill their day up with real life meetings, and so they should, but for important topics like this, we want to make the time to do them. So apologies for the early start, but at least that way it gets your day and diary cleared and off on to all the other demands that you have. As always with our webinars, and as I've just mentioned, we are recording this. It'll be up on our YouTube channel later today or later this week at the worst. So if you do need to duck off for another meeting or you want to come back to it, or indeed share it out to colleagues and such like, that will be available for you. And unless I hear otherwise from our presenters, we'll also be able to share the slides. So the best thing to do for that is to drop either Phil or myself an email, and we can get that slide pack over to you after the webinar's finished, so you don't need to be taking copious notes. Apart from that, from me, just the usual reminders. Do keep an eye out for our event emails, which are going out with notices on our upcoming events. Our website is having what you might call as a summer sit down. I don't know if it's on strike or something, but we're failing to be able to upload events to it, and our new website isn't quite over the line yet, so do keep an eye out for those emails. For those of you who like webinars, we have a GBRTT webinar to start us back in the autumn on the 6th of September around the freight growth target and different elements of reform. So that might be one to also keep a lookout for. But okay, let us move into the meat of today's webinar now, just as the last few people join us. So really delighted to be able to put on this webinar today. I can't remember how many months ago it was we last spoke about digital couplers when this piece of work first started, but it's really timely and really good to be able to share an update on that research. I'm really delighted to have colleagues with us today, Rob Staunton, Aaron Barrett and Joe Bull from RSSB, and Ralph Goldney from Railfreight Consulting, who'll be talking to us about the work programme, what's been going on, and the findings that are emerging from that. And so without further ado, let me hand over to Rob Staunton. Rob is, amongst other things, the freight lead at RSSB for their R&D programme, and is going to do us a little introductory session. So Rob, very many thanks, and over to you.
Thanks very much, Maggie. Good morning, everybody, and welcome. Today you're joining us to hear about two research projects and where we are with them. And luckily enough, both of these are coming to a close, so you're going to get a lot of information. So Ralph, if you're able to bring it onto the next slide, please. So you're going to hear today about digital auto couplers and also a project on coupler strength. And Ralph, if you can pop it into presentation mode, that'd be super. So the RSSB has always undertaken both freight-related and freight-specific work. But it became really clear at the end of 2020 that freight wanted us to do more in other areas, and we had to expand what we were doing for freight, and happily did so. We created and commenced a delivery pipeline of research, and it was put forward by and prioritized by the freight community. And that means that what you see on the next slide, the whole list of things that we're undertaking, are at your request. And as we work through these, of course, there's going to be new capacity in that pipeline. A few months ago, we did an exercise to gather up new ideas, and we have them now in place, and we will be going through the prioritization exercise, ready to reload this with new projects. Well, we have a full program, and it covers lots of important topics. And if you look at this and you think, well, it doesn't cover this topic, please drop me a line and let me know, because as we said, there's an opportunity to reload this and reframe what we're doing to add the most value for freight. So heavy access. We're also working on, sorry, back a slide, please, Ralph, sorry, oh geez. Increasing the average speed, monitoring and maintenance for freight, that opportunity to develop super fast freight and go above 75 miles an hour where it's needed most, and low carbon. So today it's about two projects. These projects have been led by Railfreight Consulting. Ralph is here to present on those, and they're both focused on couplers. But RSSB isn't, this is a really important point. We're not just focused about the delivery of the research. We want to see it implemented and we want to see it make a change so that what we talk about here today is we can put it into effect. So in the case of digital couplers, it's about answering those questions for industry. And in the case of coupler strength, it's about making sure that that makes a difference in the real world. Next slide, please. These two projects are part of a wider program. Here's all the projects listed, when we started them, and when we expect them to complete. They cover that full range of different themes. You'll be able to use this as a reference in the slides, but we send out regular packs as well with updates. And in addition to that, to make it easier for everyone to see, we've launched a new section of our website. Ralph, if you can click. So this section will include all the details that you need and easy links to where the projects are based. So with that introduction over, it'd be great if we can hand over to Ralph, who's going to take you through where we are in terms of a project on coupler strength, showing you what can be delivered in quite a short time. Thank
you. Unmute yourself, Ralph.
Yeah, sorry about that. User error happens with me. Hope you can hear me now. Okay, so as Rob said, we were fortunate enough to win through tender two research projects, and we're going to do one, then the other. And the first one is 1256, which is guidance on the limits of freight train length as governed by coupler strength. So, so I asked Bob to just talk about the genesis of this idea, and it really came from some work that I did on a new flow from the Isle of Grain in North Kent to Colnbrook, taking jet fuel to Heathrow. And the constraint was around a very short, steep gradient on the West London line between Shepherd's Bush and Willesden, which meant that this train had to be shorter than the train that previously came down from Lindsay Oil Refinery. That ran at 30, and we can only do 20. And the limit was a combination of locomotive tractive effort and also coupler strength. So so I filled in one of the forms that Rob talked about and put this into the pipeline. And in parallel with that, we took it forward with Network Rail and did some work on them and did some location-specific analysis. RSSB went through their consultation process, and this idea gained favour, but they also wanted to do some wider thinking around consulting the idea, developing a tool that the industry could use to help them calculate revised train length, and an implementation plan. Hence, they brought forward 1256. And they also wanted a quick response. They could see that there was some immediate benefits to this. And so we've completed the project in 4 months. There's an early sharing result. This is an early sharing results. The report, both of these reports aren't out yet, but the final steering group has been held on 1256. And so we're just waiting for steering group comments back, and then we're on our way. But at a very high level, we've got about 10% increase in trailing load at least, where coupler strength is an issue, and I'll come on to that. So the first recommendation is about a revision to some of the tractive effort designations. So we looked at the reserve factor, effectively the factor of safety that's inherent within the traction ratings historically. And this table at the top shows you the reserve factors on both the proof strength, which is the elastic limit, and the braking strength, which is the ultimate limit, on the 56-ton couplers and the 34.5-ton couplers, as evidenced by an old historic British Rail document called MT19. And you can see that there's different reserve factors, different factors of safety. And we carefully considered this. We looked at some other benchmarks, and we felt it was entirely appropriate to use the lower reserve factor from the 56-ton couplers on the 34.5-ton couplers, and also, so that's the first benefit, and also to extend this designation to more modern European 1.5 meganewton couplers, that are in use. And so we've ended up in an increase in traction rating, So for the The standard 34.5 ton traction rating couplers, that has now been increased to 40, or it can be increased to 40. The biggest fleets that are running around on these are the IK mega frets, but there are some cement tanks that use this as well. For a while now, Greenbrier have been fitting a European 1.5 meganewton coupler in lieu of the 56 ton coupler. And actually that's stronger than the 56 ton coupler. And so we have designated a new 63 ton traction rating. So actually, when we look at the fleet, over 50% of the fleet gets an increase in traction strength. There are around 2,000 vehicles running around at the moment with 56 ton couplers that could get upgraded to the 63 ton coupler rating, and all of the 34.5 ton can get increased to 40 ton. There's no design or remanufacture that's required. So it's not really very often that somebody offers you free stuff, but here we are, this is free stuff. So actually these coupler strengths can be increased by these amounts. And we'll go through the implementation of this towards the end. There's a couple of other quite technical recommendations that come out of this. We've looked at the wagon strength, and there are proof loads and various loading criteria. And so therefore, if we didn't cap the coupler strength, there is a danger that the wagon would fail too. And so we're suggesting that at the moment, the 63 ton traction rating, the 1.5 meganewton coupler is as far as we can go without looking at the wagon strength to confirm that it is suitable for a higher braking strength. Now, some of the wagons may be able to, almost certainly most of the wagons will be able to be strengthened, and probably it isn't a big deal, but that's outside the remit of what we're doing here. The important point is at the moment, with what we know, we can't go beyond a 63 ton coupler without looking at the wagons. And then there's a couple of very, very detailed recommendations around the design standards. There are a couple of loading criteria, one of which is not used, but is still in the design criteria, which needs to come out, which has a lower strength. And the other point is to make sure that the screw coupling actually is given a maximum strength. At the moment, there's just a minimum strength. We want to make sure that the screw coupling is always the component in the coupling that fails rather than the draw gear. And so there's a recommendation to put a maximum screw coupling strength in, which actually the Europeans do, but we don't. So just to confirm, really, there's three recommendations around new strengths for the wagons being the constraint, and these technical ones. So we then wanted to combine this, or RSSB wanted to combine this in a way that could be adopted, and we developed a tool. Now the tool, this is the input table for the tool, and it allows you to put in the mass per wagon, the wagon length, select the tractive load rating of the coupler, and so you can see here that this example here adopts the 1.5 meganewton coupling, which gives the 63 ton traction rating. So we put in the vehicle and load characteristics, and in here we put the geographical characteristics. Now we divide the track up into a series of segments in which there's no change in either horizontal or vertical alignment, and then whenever there's a change in either of those things, we make a change. So the train model enables improved length in three ways. The first of all is that we're able to select the higher traction rating, and we can do this in a way that can be followed. If appropriate, reduction in the weight of the wagon to reflect the actual loading. So there's some commodities, for instance, car carriers, where it would be very easy just to apply 100 ton gross laden weight, and that's probably the default position. And this table enables you to look at that. But probably the most important thing is it enables us to apply greater granularity to the calculation. So, for instance, it recognises that not all of the train may be on the sleepy slope. So, at the moment, the slope is applied to all of the train, and you can see that, obviously, simplistically, that's not the case. And actually, if we look at this geography over here, this is actually the West London line geography. And you can see it's quite severe gradient all the way through. But actually, the ruling grade, the one in 49, is only 106 metres long. And so this does give a benefit. Rather than applying 1 in 49 all the way through, you can see that there's some benefit there. Also, the similar benefits with the horizontal curvature. MT19 only has three criteria: sort of straight, small curve, and medium curve, a high curve. We've applied some more granularity to that. So that makes a big difference, and in some ways that's almost as important, or probably is as important, as actually the fact that you can access the higher coupler. Often some of these ramps are quite short. So we stick all of that into the tool, and it will come back with the following output, which is the number of wagons in the train, and it tells you whereabouts the key loading constraint is. You need to know where your geography is. It's worth saying that probably in the future, discussions we've had with Network Rail, you need to know where the ruling grade is before you apply that. And I think actually most operators know that intuitively, but you can't, ideally you'd say, well, I want to go from Tilbury to Trafford Park. What's the length constraint? I'm afraid you need to know the route to know where the governing grades are. And that's one for the future, maybe. We've looked at the benefits of this, and we're seeing sort of benefits of over £1,000 a train, where obviously where coupler strength and not tractive effort is the issue, and large reductions in environmental savings. So what we've done is we've taken a case study approach. We've picked 3 case studies. You can see the British Airways train, the jet to Heathrow, and we've taken 2 intermodal examples which have megafrets on them. And we've applied the modelling tool, and we've used our in-house cost model to look at the cost side of these things. So with the West London line, we improved the traction rating from 56 tonne to 63, and then the 2 IK ones have gone up to 40. And you can see that there's a 3 wagon increase here, a 2 wagon increase here, and a 4 wagon increase here. Well, if we take the Anglo-Scottish flow, long journey, it's £1,000 the train sort of price, sorry, £10,000 the train price, and actually the saving on the return journey could easily be £1,400. Now, almost certainly that isn't the right figure, but it's definitely in the right order. And so you can see that this is a significant benefit, financial saving on a single train from upgrading the couplers. Clearly, say again, tractive effort needs to be considered. But if you're already double hauling, if you're already double heading these with a pair of 88s, then maybe that's not an issue. And it's also, we've actually developed an environmental saving as well, and it's worth looking at the savings of these, which I don't think we really realise what we emit and what we save. But actually, this coupler model shows that we save 2 tonnes of CO2. I have no idea what that looks like. But I guess one way to rationalise this is to think of the amount of fuel that we would burn, and to consider that an awful lot of that weight must end up going through the exhaust of the locomotive as CO2. And so it's very interesting to see that we're getting significant reductions in CO2. And also, we're getting a lot of particulate savings as well, which isn't immediately obvious. But although this is only in grams, it's actually a huge amount of particulate savings. So notwithstanding the tractive effort, I'll say it again, that there really is some free stuff here, which is, we hope, of immense value immediately. I think Evan's going to talk through this.
Thank you very much, Ralph. Yeah, so I think it's important we've demonstrated through what Ralph has talked about and the findings that we've really got some robust findings. But it's not just enough to have some robust findings. We need to make sure that they're delivered to industry in a way that promotes their implementation. Now, part of the way that we can do this is, first of all, through demonstrating the benefits, which Ralph has just talked us through. It's also about packaging the research up in a way that supports organisations picking up that research. And we've developed the tool that will enable stakeholders to test and find out whether there is the opportunity to increase their trailing loads through this new methodology. But again, that's not enough. The support for implementation can't just end as the research ends. We need to think about the actions and the owners of what needs to come next. And through the piece of research, we developed this implementation plan. And as you can see here, there is really two streams, two suggested approaches. There's a short term, which is about things like today, first of all, disseminating the research so industry can see the findings and they can test it. There's also in the short term RSSB support. If people are interested in looking at the tool and finding out how it works, please come and speak to us. Our contact details are available at the end of this presentation. But it's also about the medium term and thinking about how do we embed these findings into industry in a way that the findings are just automatically applied. And really, there are two key actions with two stakeholders really strongly involved here. I think it's recognised at the moment through the recommendations that the project team has given us that there is no real structured way to globally challenge or update the methodology for coupler strength to determine if we can increase it. I think this is particularly important as new couplers are brought to the market with different strength characteristics. So one of the recommendations was to embed the methodology and the findings of this research into standards. And by doing that, we open up a structured route into challenging and changing the methodology in the future as that new technology comes along through those well-established standards, review and challenging processes that are open to the entire industry through the technical committees that RSSB are in charge of. In parallel to that, we're having conversation through the project team with Network Rail to ensure that these findings can be incorporated into their work that they're currently undertaking to update and digitize the loads book. And it's very important that we don't just leave these findings here to get dusty on a top shelf, but actually embed them so that actually industry don't have to think about challenging these values anymore. They're just automatically incorporated into the loads book values as they stand. So that's this project, and that was really about understanding what we can get out of existing assets. Can we increase that? And as we can see from the research, the answer is yes. Now I'm going to hand back to the project team to talk about the next piece of work. This was really about understanding, and it was undertaken in response to the looming questions of the TSI adoption of DAC. It's a challenging decision for GB, and it's one of the first decisions that we have to make since Brexit. Industry needs to make the decision, and RSSB set out this research in order to create the evidence and the data needed to inform those decisions. So I'll hand back to the project team now to talk about this research.
Okay, so this is 1264, informing the introduction of digital couplers onto the GB network. I would just say everywhere we talk about GB rather than UK because Northern Ireland is not included. So the European Union's planning mandate the installation of digital couplers, DACs, to all freight wagons through changes to the standards, and originally that was planned to come through in 2022. This meant that there would be an urgent decision required about whether we were going to take the same approach and mandate DAC, and if so, to what extent this should be mandated, and how quickly, from do nothing through to fully implement and the timings around it. So this project was established, and one of the early sponsors was the Rail Wagon Association, the RWA, to urgently provide the information to support the industry decision around the adoption of the DAC. It focused on a technical assessment, so what would be required to make it happen and how feasible is it, and then an economic assessment about is this the right thing to do. So supporting that, there are three strands to the research. There's a cost definition piece, there's a benefits definition, and then they come through to a cost benefit assessment. It's worth saying in the cost definition, you've got the core wagon fitment, but we also include locomotive fitment, fitment of enable benefits, I'll come back to that in a second, and transition costs. So just to make sure that we're all on the same page, this is what a digital autocoupler looks like. It's very similar to some of the stuff that we might see on passenger trains. At the front, it has a Scharfenberg head with a conical reception piece, which supports vehicle coupling, draws them together. Above the head is a flap which opens up, and there is a series of docks where electrical and data connections can be made. Air is connected through the head and flows through to the end. These brackets here indicate the face of the wagon. This isn't any longer than the existing DAC. This piece is within the wagon. To uncouple, you pull the handle. So it's auto couple, but manually uncouple. And this is what the Europeans know as DAC level 4. There is a DAC level 5, which is auto uncoupling, but they're not talking about moving forward with that at the moment, because that requires a higher power requirement to separate the trains. So that's what a digital autocoupler looks like on the wagon, on the face of the wagon. So just looking at the schematic, which comes from the Europeans, the DAC sits at the front of the wagon. Then through the wagon, there's conduit, and effectively there's a data plug and a power plug, probably supported by an energy storage battery, which would enable some continuity of power supply for locomotive run round and stuff like that. So you've got through connection, through the train, through the consist, through the coupler, and then through the conduit, and it provides the core infrastructure for what we suggest we call as an intelligent wagon. So you've got power to run applications, data nodes to communicate them, and so this is the digital autocoupler provides core infrastructure in itself. Now, the digital autocoupler in itself allows auto coupling. It allows you to demonstrate train integrity, if you've got a train separation, and it may give you a stronger coupler. Now, I think that's a little bit out. Not completely sure about that at the moment, though we have taken that benefit. It is a 1.5 meganewton, 1.5 meganewton coupler, but we already have a 1.5 meganewton coupler. However, the 1.5 meganewton coupler we have at the moment is actually designed to be 1.37 because it has a factor of safety within it. So we don't know whether that's the same situation in the European DAC. So it might be stronger. We'll see. So just going through some of the background information that we pulled together. We looked at the R2 database and we've come up with 13,500 wagons. We've gone through, started off with, there's quite a few vehicles in the wagons, we've cleaned that up. We've come down, we've taken a view that actually only wagons over 40 years will be upgraded. That's just an assumption that we've taken. And so we'll just say that. And we've allowed in some wagons that are going to be built during the implementation period. So you're in at about 13,500 vehicles. Not all of the vehicles are single vehicles. A single vehicle obviously needs 2 digital couplers, but quite a few of them are an outer wagon in a triple, or an inner wagon where they've got a fixed bar coupler either side. So I'm thinking maybe of some of the Network Rail fleet, or car carriers, things like that, or the inner of a triple. So we carried out a little bit of further analysis on the wagon fleet type, and we've come up with a figure of around 20,000 couplers required. So 13,500 wagons, 20,000 couplers, and around about 900 locomotives as well. So this is the breakdown of the mainline locomotives. We can argue about exactly what those numbers are, but it's of the right order. And there are, we've allowed for 150 shunters. So in terms of scope, 13,500 wagons, 20,000 digital couplers, around 900 locomotives. Now, within the assessment, there are 3 aspects to consider. I call them 3 the 3 degrees of freedom. The first thing is how much of the fleet that we convert. So scenario 1 is do nothing. Literally, you should always consider that. Scenarios 2 and 3 only require new wagons to be fitted. So eventually, over the next 40, 50, 60 years, as wagons get retired, the whole fleet will become DAC enabled. The slight difference between 2 and 3 is that 2 is all new build wagons, and 3 is new build wagons to existing designs. So there is a point that 2 allows kind of grandfather rights for old wagons to avoid design costs. Scenarios 4 and 5 are the retrofit scenarios. Scenario 4 is the entire fleet. Scenario 5 is the easiest, 88%. So we've looked at how hard the fleet would be to modify, and quite a lot of the fleet. This is mainly a spatial assessment, and with the assumption that the GSE is not going to be any longer than the existing couplers and doesn't need the full requirements of the TSI, spatial requirements of the TSI. We think that 88% of the fleet should be relatively straightforward to fit. So there's a slight difference there. So first degree of freedom, how much we do. Second degree of freedom, how quickly we do it. So going from immediate, which the EU's plan is 5 years, up to 20 years. And then finally, the level of enabled benefit. So as I said to you before, the DAC itself gives some core benefits around auto coupling, stronger coupler, train integrity, but it also provides the infrastructure to do other stuff. And this is kind of a list of the other stuff. So we have kind of enables GPS location, partial brake test, flat spot detection, derailment detection through some simple accelerometers or something like that. We've got 4 levels of what we call enabled benefits, and well, actually 5 levels including the future. And the difference between them is the power requirements, basically. As you go further down the list, as you get to things like detection of closed open doors, or actually opening doors, undertaking brake tests or electro-pneumatic braking, you're actually using the power to do stuff rather than monitor stuff. So the power requirements become more. And you can see that some of this stuff is for the future because of the power requirements. So auto coupling is DAC level 5, and certainly the operation of doors could well be a level 5. So we're just saying that there's a range of benefits here based on the power requirements that come down. So just looking at the matrix here, we've got the scenarios down the side. We've got times. We've got timings that vary, and we've also got the enabled benefits that sit within all of these options. So you actually end up with 51 different options. A very high level look at the costs, and this is the entire costs, not just wagon fitment, but includes loco fitment, transition costs. Scenario 4, the whole fleet, 600 million to 343 million. So 600 million there, 343. Basically, it costs less if you delay it, because there's an assumption that we won't retrofit wagons that are over 40 years. So if you leave it 20 years, half the fleet kind of disappears-ish, is how it works. And with scenario 5, where we're only do 88% of the fleet, is slightly cheaper again. So that's the order of costs based on the scenarios, and also based on the level of enabled benefit. So you can see that as you go through, the level of enabled benefit increases, but so does the capital cost, recognising that the scale of locomotive modifications is probably going to increase as you go through here. As you need greater power, you'll probably need to do something around the auxiliary generators on the locomotives and stuff like that. And also the stuff that you installed on the wagons is going to be more expensive as well. So you've got enabled benefits costing more, but you'll see they give you more benefits, and the timescales across the top. We've identified around £38 million worth of benefit, of which only about £17 million comes from the core functionality. The key benefits we've identified are derailment avoidance and mitigation, and train lengthening. I think this derailment avoidance mitigation is a really, really key issue. There's been a number of very well publicised, Langallet comes to mind, where actually on the last one we had a locked wheel set that ran for 16 miles and wasn't picked up. A simple driver advisory would have told the driver about that, would have prevented the derailment, the subsequent fires of the oil trains, and the contamination of the watercourse. Huge benefits, and obviously closing the line for a considerable period of time. However, if you've only got benefits of £38 million and you've got these kinds of capital costs, you can see that your business case is going to struggle. I think the other thing that I'd probably like to say is that actually it's been relatively easy to understand the costs. It's been much harder to evaluate the benefits, and there are benefits around train integrity, enabling ETS levels, level 3. This is a great example. DAC would enable ETC level 3. It would allow you to know the train's integrity status, make sure there's no separations, but also very clearly tell you where the end of the train is. However, there's no commitment to go to ETCS level 3, and so we can't really, in all honesty, take a benefit from it. And this is the sort of conditional stuff that we're seeing all of the time. So I'll make that point. Costs, we can all understand them. Benefits, much harder. So when we move forward to the benefit cost ratio, we've effectively taken the cost, the benefits over a 30-year horizon, discounted them as appropriate in line with HMT's Green Book. We end up with these benefits. Now, scenario 1, do nothing. There's no benefit, clearly. But of course, there's no capital cost. The UK will diverge from the European Union. We will have some costs around a smaller supply market. We'll have some difficulties with channel tunnel traffic. We'll either have to manage through the use of barrier vehicles or making HS1 its own separate little network and converting the 92s or something like that. So scenario 1, no benefits but no capital cost. Scenario 2 and 3 have the best business cases, and in fact the only business cases that are over 1. But we will have the operational complexity of operating mixed fleets, both DAC and conventional, for years and years. And also there will be a separate issue that new vehicles, new wagons that have DAC will be considerably more expensive, and also will require locomotives fitted to be retrofitted to use them. And so it'll actually discourage investment in new vehicles. So we don't suggest that if we're going down on DAC, we do that. And then within the entire fleet, all of the business cases are less than 1. Even for scenario 5, where we're only doing, inverted commas, the easiest fleet, well, we don't get above 0.82. Now, that is all it is. Other stuff that I'd like to point out from this is that generally the enable benefits substantially increase the business case. So if you're going to do it, it makes sense to have the business cases as you move to the right down all of these things. Then generally the BCR improves. Also, generally, as you go down the list, as you take more time to do it, the benefit to cost ratio improves. And that's because we're doing less wagons. Now, if the benefits were stronger, I think that position would be reversed and the implementation would be much quicker. And one of the reasons that the EU are saying that they should do it within 5 years is that they have a stronger benefits case, or they say they have a stronger benefits case. And so they want to do it as fast as possible. Our view on timescales, we don't say it here, is that if we were going to do it, we suggest we did it as fast as possible within 10 years, but we did it in a staged approach. But there isn't a positive business case. So I've kind of talked through this. All business cases less than 1. Enable benefits increase the benefits cost ratio, and long timescales are better. I think the conclusion is that at the moment, this is all about being in a position to respond to changes to the tier size. But at the moment, the EU's decision is unformed. They haven't published their benefits case yet. That was due in Q2 this year and still hasn't come out. So it'll be interesting to see what happens there. And also, they're still developing their specification around power and data. But when that decision comes out, we'll be in a better place to respond. As I said previously, it's been hard to get commitment to the benefits. And the final point is to say that enable benefits indicate value. And maybe there's a better business case, enabling intelligent wagons but without a new coupler. The coupler in itself, the core benefits aren't that great. And you would still keep some of the core benefits if you, for instance, provided the inter-wagon connectivity through a jumper cable. So maybe it's a better case without a new coupler, but having intelligent wagons. I can certainly see that that would be an attractive thing. And if that was the case, the faster fitment would then produce a better business case ratio, benefits cost ratio. So over to Joe for the final slide, I think.
Yep, thanks very much. So hi everyone, I'm Joe Bull, Regulatory Policy Specialist at RSSB in the Standards Directorate. So my role in this comes with the link to standards and the technical specifications for interoperability and therefore the national technical specification notices. So just to kind of briefly cover what next for industry on DAC. So firstly, as Ralph was just saying, the European movement. So there's still appetite for DAC in the EU. So there's still a lot of work going on the European DAC delivery programme, the EDDP. So work continues on that. There will be some sort of passing reference to DAC in the next set of the EU's TSIs, we think. That's kind of been put in there to make sure that this stays in the frame for consideration. But we don't think there will be any requirements included in the next TSI on DAC. So again, kind of as Ralph was saying, the European cost benefit analysis work wasn't really complete in the timescales that they'd hoped. And also a plan for funding and financing in Europe hasn't been agreed yet. So this has pushed back the decision on implementation in the EU. So we now expect this will be implemented through the TSI published in 2025. In the meantime, the ERA are publishing a technical report showing the current state of development of the specification of DAC. So what this means for us really is that the evidence base for a GB decision on DAC will need to keep evolving as the European work develops. We particularly are still plugged into the EDDP, the work that's going on, and we need to keep monitoring this to understand how this might change the case in GB when things change. For example, changes to the assumptions of the expected costs or the plan for migration and some feasible dates for this. And we need to update the case to reflect this. If the case in GB remains kind of as now, likely to depend a lot on the enabled benefits, then we need to understand obviously more about these and how this fits with kind of wider industry strategy. And similarly, if there's an alternative way of getting the same benefits, then we need to understand this a bit further too, just to confirm that DAC is actually the right solution to the strategic need to modernize and bring efficiencies. In terms of timescales, so when this work started, the work was very urgent and has been delivered rapidly as a result. Now with the slight delays in Europe, the urgency's lessened, but the question has not gone away. So a decision for GB will still be needed at some point. I guess the main point is now that we're on the front foot with this, and this work and the foundation that it sets means that we're able to keep updating our understanding and be able to react quickly to EU specifications. So once there's a bit more certainty about the position in the EU, so for example, seeing this positive economic assessment and there being an agreement on funding and financing arrangements that will actually make this a reality, then there can be a decision for DAC in GB. Now, the decision itself will ultimately be by the DFT if the requirements are set through the National Technical Specification Notices, but it will be informed by industry through recommendations that RSSB will coordinate following decisions that will be made at the WAG NTSN Mirror Group, Rolling Stock Standards Committee, and through a full wider industry consultation. But if this is going to rely on government funding, as it well might, then it will obviously need DFT buy-in, and these discussions will basically need to start as soon as a positive case is established. So I hope this discussion outlines really how RSSB's responded quickly to this need from the freight sector, and we'll continue to work with partners to deliver valuable research in this and other areas to support the industry with answers and practical solutions. If I leave it there and if I hand back over to Phil or Maggie, and we can take questions on this.
Thank you very much, Joe, Aaron, Ralph. Whoever's on the slides, Ralph, could you just drop them? Thank you. And then it was remiss of me to say, and then I will hand over to Phil, if you've got questions, please put them in the Q&A box. I can see we've got one or two there, but we've got you know, plenty of time now to take questions. So please do, and Phil's going to take us through that. Thank you.
Great, thanks Maggie, and thanks to Ralph, Aaron, Joe, and Robert. Yeah, so as Maggie says, if you've got any questions, stick them in the Q&A or the chat if you can't find the Q&A. We've had one question in that goes back to the earlier piece on 1256, and it's from Mario Ramos Garcia. How does the recommended changes in traction affect the fatigue behaviour of the couplers? From the shown information, it looks like only yield strength and ultimate strength were considered. Who wants to take that one?
So I better take that one. And actually, Mitch Town is as part of our project team, and Mitch is on the call, and they're most of the mechanical pieces. Mitch, would you mind responding to this?
I've clicked allow to talk, Mitch, so you should be able to do that if you come off mute.
That's assuming he hasn't gone for a cup of tea.
Yeah, can you hear me?
We can hear you.
Hello, yes, so I thought I'd come off mute already. I was chatting away, sorry. Yep, the GB system, actually, there is no historical approach to fatigue for couplers and coupling systems. There is, however, a set of fatigue loads in the European system. So in the Euronorm, there are fatigue loads specified there. And I guess what we have done subconsciously is read across from one to the other. The European system, the designations in there and the loads are very similar to ours, albeit a little bit higher or a little bit lower in some cases. But essentially they're very similar, and the fatigue loads in there therefore would read across to ours. And the fundamental design of these things is the same across the board. So we've no reason to suspect that the fatigue behavior would be worsened by this increase. That's the short of it, really. So is that a good enough explanation?
Thank you very much for that. I guess the question will have to post another one if they want to take that any further. Yeah, thank you for the answer, says Mario. So that's all done and dusted. Right, moving on then. We've got one from Joseph Brown. Has any thought been given to how implementation of DAC would be financed? Would it be funded via the DFT, or would operators be expected to finance it themselves, both for new wagons and retrofitting? I guess that is the biggest question of all.
Yeah.
Yeah.
Go on, Joseph.
Sorry, I can start to answer this, and then feel free to kind of take over as well, Ralph. I think the challenge. I mean, certainly this is a challenge, and I think this is a lot of the reason why possibly this is going slightly slower in Europe than we had thought it would around a year ago with the discussions over funding and financing. I think part of the challenge with this, and I think this is what the work that Ralph's done has really flushed out, is the slight dislocation of where the benefits are and where the costs might be assumed to be, in that there are kind of a range of benefits that aren't necessarily just to freight operators. So obviously with a lot of the enabled benefits as well, there's a link to Network Rail and therefore kind of benefits for wider industry. I think the purpose of doing this work really was to be able to set that out and then to be able to share the case with the DFT to kind of start off these type of discussions. I suppose the challenge with that at the moment is, given that the European case is still not kind of fully formed and there are still some open questions around this, that probably the timing is not quite right to do that just yet until we have a sort of a firmer picture.
Great, thanks. I expect on behalf of our members, the view will be taken is that we wouldn't mind chipping in, but we'd have to identify, I guess, those benefits that would derive to the operators, and then the other benefits have to be financed externally. Okay, moving on to Julian. This is a question for Ralph. Does the 4 extra wagons on the Anglo-Scottish assume fully loaded IKAs? In practice, the load is rarely more than 30 tonnes, so potentially even more wagons could be hauled.
The answer is yes and yes. So you're absolutely right, Julian, and that's why we've put the functionality in the model. We didn't go there on this, but absolutely right.
Great. And from Richard Moore, if DAC without automatic coupler is considered, using a simple jumper cable, has the cost-benefit analysis been undertaken?
No, we discussed this, Richard, but it's a question of where you draw the line. There's no specification for that, and our evaluations around short coupler. It's something that could be considered. What we haven't really made reference to is that there are some very detailed supporting cost spreadsheets that members of the steering group will have already have seen, and so RSSB could think about that or whatever. But that information is available to be considered.
Just to pitch in on that,
I guess we'd be looking to Europe to see whether this is going to move forward or not, and then there would have to be another decision to undertake a separate project around alternatives to DAC if that was decided to be the way to go. Sorry, Robert, I think
that's correct, Phil. It's just that now we're in this moment of interplay between Europe and this decision. The DAC decision is not finished yet. This is our current position based on the information we can gather, and we hope the presenters emphasize that what we have to do is keep this system and this cost-benefit analysis live. So as new info comes in, now as it settles in and the information becomes more steady state, and then the UK GB can make a very informed decision about what we're going to do. In the meantime, we know that this decision polarizes industry. On one side, we have people who say DAC is the future. We need to accept it. We need to adapt it. And the quicker we do it, the better. And then we're advancing freight. We're investing now for a better future. Others say our system is different and we don't want DAC. But the reflection for those people who say that our system is different and we don't want DAC is, are you now thinking about what the costs are, what the benefits are, and what your investment is like for solutions like jumper cables or entirely wireless systems based off telecom systems and energy harvesting? And so either way, I think within freight, people need to be thinking about their investment and their development costs and watching out for new technologies. But the RSSB is going to stay on top of this, and we'll be there to respond and help people. And we have that research capability that we can begin those pieces of work once we know that there's a high certainty of which direction we're going to go. So we're prepped, we're primed, we're ready to bolt, but let's just hold tight for a little while longer.
Okay, and I guess that answers the next question from Julian Worth, which is, could RSSB now look at other ways of securing the main wins of DAC, heavier trains and derailment detection? And he puts in AAR type knuckle couplers and wagon mounted devices with internet communication rather than hard wires along the train could achieve the objective. But I guess that would have to form part of the next phase of work if we didn't go down the DAC route.
And this work really does inform that when you see things like this come up in early research, in new technology development from companies, everybody should now be paying attention to these and watching them as well, which is always a healthy thing to do.
Indeed. Right. One from Steve Taylor. RAIB recommendation 7 requires Network Rail in conjunction with RSSB to review and plan for equipment installed on wagons to detect and alert safety critical fault. Does this help or hinder the DAC decision?
The RIOB recommendations really focus our mind on what needs to happen and the direction in which industry needs to go. I think what may be within that is around looking at new technologies and new couplers, which is the point that we've made. And I think what we need to do is for industry to continue to remember this, that it's not just a DRM, it's the subsequent costs that come with it. And Ralph's work in this really tried to pull out where some of those benefits could lie. And it's not, incidents like this don't disappear from memory quickly. We don't know what will happen in the future. We don't know how our decisions around couplers could be impacted by the next major incident. So it definitely adds to the focus that industry are making. And we know that the direction in the future is a more intelligent system where we know what is happening and what our consist is doing as we travel, because you can't run for that long knowing that with a major issue and not know anything about it. And there's multiple solutions to that. It's a very exciting space. And you'll see that we begin to drop in new questions of alternative ways as well, which could fix that in the medium term within our research pipeline.
Great, thanks. Any other questions from anybody?
We've got 4 minutes.
We've got
so,
just a few minutes.
Unless anybody else drops one in, I just wanted to a quick question for RSSB colleagues. Really, I think you've already said it, but just remind our audience about the pipeline, what's coming next, and how they can get in touch if they've got any bright ideas that aren't already in the pipeline. Because I think what this webinar is showing is, you know, that the pipeline approach that we've taken is generating out projects which are delivering, you know, really valuable bits of research, both in terms of, you know, the first one where Ralph managed to find some stuff for free, which never happens. But you know, in the second case, really, you know, solid work that not only helps to inform the decision point now, but sets out a framework that can do that evolution, Rob, that you spoke about. So I guess what's up next?
Aaron, perhaps if you cover what's up next, and then I can cover how people can contribute and shape what the future looks like.
Yep, absolutely. So I think keeping on the question of the values in the loads book, the quick win that we identified with the coupler strength project, we're hoping we can find something similar if we look at tractive effort of locos. We know that there hasn't been a comprehensive review of those values since the introduction of the 66. So if we can create a methodology for assessing the newer locomotives, also reassessing values of for older locomotives, we're hoping there'll be some quick wins there as well. But anyway, providing that framework to determine what those values should be will be a win in and of itself. There's a number of other projects that we're looking to undertake as well. We recently completed a piece of work looking at heavy axle weight and the effect on the network. We're looking to move that into a model. This will be a long-term project or a medium-term project over the next few years, to develop a model which will make predictions around route accessibility and availability based on the current usage and potential future usage of heavy axle weights as well. We also want to look at things like sectional running times. There's long been a suspicion that the sectional running times for freight, particularly heavy axle weight freight, is not particularly as robust as it could be, and there may be opportunities again for some quick wins on better reflecting sectional running times that align to the capabilities of locos as well. Rob, there are a couple of other projects if you'd like to identify any of the other ones which you think are of note as well.
On the fly, I'd say I'll refer to people in the slide deck. So really do get your hands on this slide deck and have a look at the freight website. That program is there. In the background now, that Ralph really had this idea and he submitted it. Now, it wasn't expected that he would be able to deliver it, but it's an important message for everybody that if you've got something and you think, why don't we do this? I think there's something there. This project really demonstrates how 10% could be sitting there for free, hidden away. So we have to identify those. It was the freight community who said, actually, let's run with this, let's go for it. And you can see a result here. So submit your ideas. You can do that through the website. There's an idea submission form. Our contact details are going to be included in the slide deck. So just get in touch. We can have a chat and we can shape it. Now, this is I'd say a competitive, aggressive pipeline, which is a little different to sometimes how we do things at RSSB. Our program of research is oversubscribed, so we have to pick our projects well. We've got a great team of analysts, of which Aaron is the lead analyst, who can determine which ideas have got the highest potential. We're going to go with those ideas that have the highest potential. So our pipeline is not set, it's going to be adaptive, and it will be reactive to the new ideas that we receive. We want to make the biggest difference that we can. And that's an important message, is that RSSB want to do this work now. It's very useful that we've got that consistency of delivery. We can commence this work. We've got great links and discussions happening with Network Rail and with GBR, and that they're really keen to see that we get these projects moving and started and get that benefit in place now. So please overload us now so that we can find the best ones and start them.
Brilliant.
Thanks, Robert. Without wishing to overburden you still further, I gather the report on the digital automatic couplers has now been published, but is open for comment until the 8th of August, is that right? So if anyone's got any further questions, they can get back to you on that, is that right?
Not actually published yet. This is us being brave today.
Oh, right.
We are providing those early findings to industry so that people aren't left guessing until a big unveil. When we know the information, we want to get people that key message out there. So our steering group now is going through the comments and shaping that final report, getting it fit. We want to make sure that, particularly with the DAC one, that it's in good shape and well phrased, because this is going to be picked up again and again over the next while. So this is an early reveal. On the couplers one, you'll get the coupler strength project. You'll get that quite soon.
So you've seen the documents because they've been shared because you're part of the steering group, and some of the people that are part of this have seen them. So it's for the steering group consultation and final comment at the moment.
Lovely. Well, we're all about to go off on holiday, so whilst we're away, you lot can beaver away on those drafts, and then we'll have something to look forward to on our return from sunnier climes or wetter climes or wherever it is we're heading. But look, we are bang on time. So I'm just going to say huge thank you, Rob, Aaron, Joe, and of course Ralph, for not only today's webinar but all the work that's gone behind that. It's really good of you to share it at this stage, and I think it's, you know, actually we're sitting here today with the trains on strike and funding crises and hot weather and rail reform going bang, and actually to know that out there there's, you know, really solid research going on that's identifying, you know, solid benefits, and even where there aren't solid benefits, advancing the thinking and the understanding, I think is really rewarding. And, you know, I couldn't agree more, Aaron, with your list of things that we need to move on to next as well. You know, that they're in that space of things that will make, you know, lots of 10% differences add up to a lot, you know, a lot of gain for the sector. So thank you all. I think when you get through to the publication of those reports, you know, there's some really nice case studies here, and we'll be very happy to have a chat about putting them into RFG News or any other promotion that we could help to give them, so that people who haven't been able to come on today can see that. But thank you all for taking the time to speak. Thank you to all of you who've joined us for this webinar this morning. As I've said, it will be up on our YouTube channel. If you want the slides, drop Phil or myself an email and we will get them over to you. And no doubt we will do this again at some future point as that research pipeline keeps moving forward. But for now, that's all. Thank you very much and enjoy the rest of your day.